for our prayer to be led to us by Renny Rose. Amen. So good morning, class. Before you take your seats, kindly pick some pieces of papers and arrange yourselves. Make yourself comfortable before we start our discussion. So you may now have your seats. So before going to our new topic for today, let us review first our topic for last week. So who among you here can recall what is our topic last week? Anyone? Okay, Jessie. Thank you. Very good. And Rafi? Okay, very good. So our topic last week was all about the basic differentiation rules, but it is all about the identity rule and the constant rule. So for today, we will be having a new set of learning, and I hope that you must listen because it is very important and it is also relevant for our succeeding lessons. So before I introduce our new topic for today, I would like you to read the objectives that we will have for our lesson. Okay, thank you. So that is our aims that we need to attain this morning. And our topic for today is the basic differentiation rules for derivatives. So who among you here has the idea of differentiation? Okay. Thank you. So differentiation is the process that we will find the derivative of a given function. And today, we will have three basic rules of differentiation. That is the power rule, the constant multiple rule, and sum and difference rule. So the first rule we will have is the power rule. So the definition of power rule is if y is equal to f of x is equal to x raised to n, where x is a differentiable function and n is a real number, then y prime is equal to n times x raised to n minus 1, or f prime x is equal to n times x raised to n minus 1. So, in finding the derivative using the power rule, let us remember that just make the exponent as the numerical coefficient and subtract 1 from the given exponent of the variable x. Then, simplify the derivative if they are not in their simplest forms. So, we have an example here. So, f of x is equal to x raised to 4. So, the process is f prime of x is equal to n times x raised to n minus 1. So, let us identify that x here is our x value and n is our exponent, which is 4. So, let us now substitute the values. So, our n is 4 because it is our exponent, then x. Then our exponent is 4 minus 1. So the derivative, or the f prime of x, is equal to 4x raised 4x cubed. So have you get it? Y is equal to x raised to the power of 10. Then y prime of x is equal to, what is our exponent? 10. 10x raised to the power of 10 minus 1. Then, y prime of x is equal to 10x raised to the power of 9. As easy as that. That is how power rule works. The third example is y is equal to x raised to the power of 25. Let's just do the same process. Y prime of x is equal to, what is our n value? Okay, good. That is 25. 25x raised to the power of 25 minus 1. Then y prime of x is equal to 25x raised to the power of 24. And for our last example, we have here a radical expression. We need to make it as f of x is equal to x raised to negative 1. Then, since it has the same phase as the other examples, we can now apply our power rule. So, what is our n value? Class? Okay, good. Negative 1. So, f prime of x is equal to negative 1 x raised to negative 1 minus 1. Then, f prime of x is equal to negative 1x, negative 1 minus 1. What is the answer? Okay, good. That is negative 2. So, f prime of x is equal to, radical is mainly a fraction. So, it has the numerator and denominator. So, negative 1 will remain as the numerator, while x is here at the denominator side, and the negative 2, which is the exponent, will change its sign. It will become positive. So, are you still there? Okay. So, let us proceed to our second rule, the constant multiple rule. So, its definition: if y is equal to f of x is equal to constant multiplied by f of x, where u of x is a differentiable function, then y prime is equal to c multiplied by f of x, or f prime of x is equal to the constant multiplied by f prime of x. So let us remember that in applying this rule, first we have to multiply the exponent by the numerical coefficient of the given function. So, if here in the power rule, the exponent will become the numerical coefficient, here in the constant multiple rule, since it already has a numerical coefficient, the exponent will be multiplied in the numerical coefficient of x. So, here in our first example, our numerical coefficient is 3 and our exponent is 2. Next one is subtract 1 from the exponent of the given function and simplify the resulting derivatives. Just like here in the power rule, the exponent will be subtracted by 1. So let us now clarify the first example. Y is equal to 3x squared. So y prime is equal to 3 multiplied by 2, x 2 minus 1 squared minus 1. So 3 is our numerical coefficient and multiplied by the exponent of x, which is 2, then the exponent will be subtracted by 1. So 3 times 2, okay, it's 6. And x, and 2 minus 1, 2. So, the final answer is, or the first derivative is, y prime is equal to 6x. As easy as that. Then the second example, f of x is equal to 5x raised to the power of 9. So, how we're going to solve it? First, let us identify the numerical coefficient. It is 5. Then our exponent, it is 9. So, f prime of x is equal to 5 multiplied by our exponent, which is 9, and x raised to the power of 9 minus 1. then f prime of x is equal to 9 times 5 is equal to 45 x 9 minus 1, 8. So this will be our first derivative of the function f of x is equal to 5x raised to the power of 9. And for our last example for this constant multiple rule, it would be y prime is equal to 4 multiplied by 7 x 7 minus 1. Y prime is equal to 7 times 4, 28. 28x 6. So let us now proceed to our last rule that we will discuss today, the sum and difference rule. This rule includes addition and subtraction. So this is the definition of sum and difference rule. If y is equal to f of x is equal to u of x plus minus v of x, where u and v are differentiable function, then y prime is equal to u prime of x plus minus v prime of x, or f of x, or f prime of x is equal to u prime of x plus minus v prime of x. So let us remember that in using this rule, first is we need to get the derivative of each term by applying the previously discussed rules and finding the derivatives. And after we have solved the derivative of each term, then we must simplify the derivatives if they are not in their simplified forms. So we have here our first example. Y is equal to 3x squared plus 2x minus 5. As you can see, it includes operations, addition, and subtraction. So the first thing that we need to do is to solve the derivative of each term. So 3x squared prime plus 2x prime minus 5 prime. In doing this rule, you need to know or to familiarize the other rules that we have previously discussed: the constant rule, the identity rule, the power rule, and the constant multiple rule. So for our first term, it is applied by the constant multiple rule since it has the numerical coefficient and the exponent. So what are we going to do now? The numerical coefficient will be multiplied to the exponent, which is 2. Then x is 2 minus 1. Then it will be having the result of 6x. 3 times 2 is equal to 6. Then x. 2 minus 1, it will have 1, automatically 1 exponent. Then plus 2x 1 minus 1. Then it will have 2. Then 5. What is the prime? What is the derivative of 5? Since it is a constant, then it will have the derivative of 0. So our derivative for this given function is y prime is equal to 6x plus 2. Then let us now proceed to our second example. F of x is equal to 4x raised to the 6th power minus 9x cubed plus 3x squared. So f prime of x is equal to 4x raised to the 6th power prime minus 9x cubed prime plus 3x squared prime. Then f prime of x is equal to, what is the process that we were going to apply here? It is still the constant multiple rule. So 4, the numerical coefficient, multiplied by the exponent, then x, 6 minus 1 minus 9 9 times the exponent, which is 3, and x, 3 minus 1. Then, plus 3 times 2. 3 times 2, then x is equal to 2 minus 1. So let us now have our final answer. F prime of x is equal to 4 times 6. It is 24. Am I right, class? It is 24, right? 24 x, then 6 minus 1, 5, minus 9 times 3. 9 times 3 is equal to 27. 27x squared plus 3 times 2, 6. 6x. So this is our first derivative of the given function. And for our last example, f prime of x is equal to 5x raised to the 4th power prime minus 3x raised to the power of 11 prime. Then what is the process? Still the constant multiple rule. Negative 5 times 4x, 4 minus 1 minus 3 times 11 x, 11 minus 1. So our final answer is f prime of x is equal to negative 5 times 4, negative 20. Negative 20 x, 4 minus 1 is 3, or negative 20 x cubed, minus 3 times 11. 3 times 11 is equal to 33x raised to the power of 10. So that is our examples for our 3 different rules for finding the derivatives of the given function. Since you have already understood our lesson, I will now give you an activity, a seat work. So this is an individual activity that you will answer at your seats. Here is your activity. It is only a 5-item activity. So this activity includes examples of power rule, constant multiple rule, and sum and difference rule. So answer it because you will be going to pass it at this class. While you are answering, I would like to say thank you for listening to our lesson, and I hope that you have understand well our discussion because it is a continuation of our discussion last week, which are some of the basic differentiation rules as well, the identity rule and the constant rule. But as we go on with our discussion, we will be having more complex lessons. So you must study in advance, and as a mathematics major, I will expect you to know the lessons. So are you done with your activity? So John Ray, can you collect the papers and pass it to me after this class? So pass your papers to John Ray, those who have finished their activities. Okay, everyone, listen. So our assignment for next week to do some research of some of the basic differentiation rules for derivatives. So, hindi pa yan lahat o hindi ito lang yung mga basic rules for differentiation. We still got a lot of rules that we will discuss as we go on with our lessons. So I want you to do some research about it, study, and give at least 3 examples each. Don't forget that it will be passed next week, Monday. Write it on a yellow paper and give at least 3 examples. So that will be all for today. Thank you, class, and may you have a great day, and may you have a new sets of learning and new sets of knowledge that will be useful for your future endeavor.